As can be seen in this pull-down menu, there are 4 ways to randomize the data or the deep structures in the efficient cause analysis procedure. Now, as a reminder, randomization tests are a tool that we can use to choose between 2 competing explanations for the patterns we observe in our data. Now, is the pattern we see here best explained by our theory, or is it best explained as the product of physical chance? Now, when we obtain a chance value or C value that is close to 0, as is the case here, then we reject the physical chance interpretation and instead conclude that our theory stands as the more plausible explanation of the observed data pattern. Now, in this case, we would conclude that feelings of anxiety are causally connected to feelings of stress. Now, the specific nature of the physical chance inference changes depending upon the randomization method chosen. Now, here you see some PowerPoint slides that explain these changes. You can download these slides from the OOM website. And I'll just scroll through a few of them here so you can see that they explain the different randomization methods and the inferences pertaining thereto. How exactly do these randomization methods work? Well, let's begin with the randomize within effects orderings method. Here's the anxiety and stress ratings graph we've seen in previous videos. Now, the bottom graph here shows one instance in which the effect orderings have been randomized across the 53 days. Note that the red line has not changed from the top graph. We've only randomly shuffled the values constituting the blue line. So we've randomized within the effect orderings. That is, we've randomized the stress rating values across the 53 days. Now, in this particular instance, the PCC has dropped to 36%. But now imagine performing this randomization process 1,000 times and collecting these PCCs. And when I ran the analysis in the OM software, not one time in 1,000 trials did I obtain a PCC index of 70% or higher. The chance value is therefore less than 0.001 or less than 1 in 1,000. And that means we would conclude that our causal theory is the more plausible explanation of the correspondence we see between the anxiety and stress ratings in the graph. Now, with the randomized within cause and effect orderings, we randomly shuffle the values within each set of the orderings. Now, notice how the red and blue lines now appear different in the bottom graph. In particular, notice how the missing data point for the anxiety rating on day 43 has been randomly moved to day 39. Again, we're randomly shuffling the observations themselves, but now separately for the cause and the effect orderings. Now, in this particular iteration, the PCC dropped to 46%. And when I ran the analysis in the OM software, not one time in 1,000 trials did I obtain a PCC index of 70% or higher with this particular randomization method. Again, that would support then the theoretical inference. With the randomize all observations option, we randomly shuffle all of the values in this top graph, both across the 53 days and across the cause and effect orderings. Now, notice how the missing red data point for the anxiety rating on day 43 has been randomly moved to day 18 as a blue stress rating. So again, we're randomly shuffling the observations themselves, but now both across days and across lines. Now, in this particular iteration, the PCC index has dropped to 38%. And when I ran the analysis in the OOM software, again, not one time in 1,000 trials did I obtain a PCC index of 70% or higher, again, supporting the theoretical inference. Finally, the randomized deep structures option is different from the other 3 in that new data are generated. So notice, for example, with the original data, only a single value of 10 for the anxiety ratings was observed. But now with the randomized deep structures in the bottom graph, we see 5 values of 10 for the anxiety ratings. So therefore, new data based on the units of observation for the cause and the effect orderings are being generated with this randomization option. Each of the 0 to 10 units has an equal probability of being generated, and for this particular randomization, the PCC index dropped from 70% to 40.38%. As with the 3 previous methods, the eye test reveals little correspondence between the patterns of the 2 randomized lines. So finally, when I ran the analysis again in the OM software, the chance value was less than 0.001. For these anxiety and stress ratings then, the C value was the same and supported choosing the theoretical interpretation over physical chance. Now, such an outcome will not always be the case. The chance values are not always going to match up, in other words, across the 4 randomization methods. So you'll need to study the downloadable PowerPoint slides carefully and choose the randomization method that best matches your intentions.